Welcome in the second part of project Coughin Dance. In this part I will introduce functions, lists and iteration, and if you are already familiar with all these concepts in SuperCollider, feel free to skip to the next video. This is the SuperCollider IDE. In the SuperCollider IDE you can execute code blocks. Code blocks are pieces of code in between these round brackets, and the IDE will normally highlight the complete block when you put your cursor after the last bracket of the block. You can execute such a block by pressing Ctrl Enter or by pressing Command Enter on a Mac. What are functions? Functions are a way to wrap up functionality under a neat name. For example, here I define a function f, and defining functions happens by using curly brackets. And something special in SuperCollider, especially if you come from other programming languages, is that you can store functions in variables. Function f is taking two arguments, an argument a and b, and it returns the sum of a and b. And in general, the last thing that you put in a function, the last line in your function, is what is returned from the function as a result. Now we have to learn how to call a function. So we've defined our function f to calculate the sum of two arguments a and b. And if you want to actually calculate a sum, we have to call .value on the function. We can calculate the sum of 4 and 5. Here we have a separate call, a different call where we calculate the sum of a list of numbers and a single number. And then we have a call where we calculate the sum of two lists. And let's execute this code and see what happens in the post window. So the f value of 4 and 5 gives 9, as we expect. The sum of a list of numbers with a single number adds that single number to every element of the list. And if you add together two lists of numbers, the elements are added element-wise, so 4 plus 1, 5 plus 2, 6 plus 3, and 7 plus 4. Instead of using these pipe characters to indicate the arguments of a function, you can also just use the arg keyword. It's exactly the same, just a different notation. Some people prefer this, but I like the pipe characters because they make it very visual what are the arguments of a function. Apart from this arg word, everything behaves the same as before, so nothing special there. If you create lots of functions and you have to call a lot of functions, always typing this .value can be a bit annoying, and so SuperCollider provides a syntax shortcut. And you can leave out this you can leave out the word value if you call a function. So you just put f dot and then 4 and 5 as arguments. So let's try it out. We again get the sum of 4 and 5. That's all I wanted to say about functions for now. Let's switch to lists. What are lists? Lists are a collection of elements. And here I have a list of numbers, but you can also make a list of strings, or you can make a list of mixed types, and many things are possible. What can you do with lists? Well, you can get elements out of a list. And the first element in the list gets index 0. So that's something that's quite usual in programming languages, that we count from 0. I have to evaluate a complete block. If I get list element 0, so that's the first element in the list, I get 10. If I get the third element in the list, that's 0, 1, 2, 3, I get 40. Lists support a number of methods. In fact, they support many methods, but I'm only going to show those that I'm going to use in the tutorial. If you call first on a list, you get, no surprise there, you get the first element in the list. That's element 0 if you use with index notation. And if you call .last on the list, then we expect to get 50, and indeed we get 50. We can also call reverse on the list, and that will result in the same list written backwards. So the reverse of the list gives you 50, 40, 30, 20, 10. Then, given a list, we can add extra items into it with the add method. For example, I'm adding here element 10,000 to the list. And something to remember is whenever you add something to a list, you have to assign the outcome of the add operation back into the list. Otherwise, you can randomly lose elements. When we do that, we see that indeed the new list now contains this extra element 10,000. And SuperCollider again has a shortcut syntax with this double plus. You can use the double plus to also add elements into the list. So into the list I'm now also adding this element 20,000. And indeed you see here the extra element 20,000. You can also get values out of the list. And one method we will use is pop. Pop will remove the element at the end of the list, the last element in the list. And what pop returns is not the new list with the element removed, but just the element that was removed itself. So if you call pop and you debug the return value to the post window, you see just the element that is removed. And if you then print the list after the pop operation to the post window, you see that indeed the element 20,000 has been removed. Then we need also something to create lists, and one way to create lists is to use the dup operator. What this does is it duplicates a given number or a given element, and here we duplicate it 3 times. So we expect, as a result of this operation, we expect a list of 3 5s, and indeed that's what we get, a list of 3 5s. And as an alternative notation, you can use this exclamation mark, which is exactly the same as .dup. So here again, we expect a list of 3 5s, and that's exactly what we get. So let's continue now with iteration. Iteration is a very powerful concept, and it is used to iterate, to go over elements of a collection, usually one by one. So for example, I here have a list with 3 numbers, and I call do on that list. And do takes a function which you can recognize because it's between curly brackets. And the function takes 2 arguments, an element and an index. So what will happen? For every element in the list, this do will execute this function. And every time it executes the function, the element that is currently being visited will be this L, and index will be the index in the list. So let's try it out. If we call do on the list of 5, 8 and 9, and in every iteration we print out element at index was visited to the post window, we see indeed that element 5 at index 0 was visited, element 8 at index 1 was visited, and element 9 at index 2 was visited. So with do you can do something to every element in a list. And there's again a shortcut syntax in SuperCollider. Whenever you have a round bracket followed by a curly bracket, you can leave out the round bracket. So this do on a list we can also write with just the curly brackets. This may seem insignificant at the moment, but I can assure you, as you go further in SuperCollider, you will be glad for many of those shortcuts. Okay, a different form of do just operates on a number. So now we don't have a list to iterate over, but we iterate over a number. And what does that mean? When you iterate over a number, an integer number, then it will make a list internally itself from 0 until that number, or that number minus 1. So you see here element 0 at index 0 was visited 1, 2, 3 and 4. 5 itself is not included. So this tells you the number of iterations from 0 to 4 and not the final element that will be part of the iteration. That's what I wanted to tell you about the do iteration, but there are different other forms of iteration, and one is collect. So collect will again iterate over or go over every element in a list, but it will also call a function on that list, and again I used the shortcut notation, so I left out the round brackets. And what will happen as a result of collect, you will not get just executions of functions, but you will get a new list. where every element in the new list is transformed according to the function that was passed into collect. So for example here, if we have 5, 6, 7 and we call collect on it and we do every time element plus 1, we expect to see a new list with 6, 7 and 8 as elements. And that's exactly what happens. I here used collect to add 1 to every element of the list, but as I mentioned before, you can do arithmetic on lists just by adding a number to a list as well. So for this simple use case, you don't need collect, but for many more complex functions, collect will be very handy. And there are also some other forms of iteration. For example, the do adjacent pairs iteration will go over a list and take in 2 elements each time. So the first time you call this function will be with element 1 equal to 1, element 2 equal to 2, and index equal to 0. And the second time you call it, it will shift everything, and element 1 will be 2, element 2 will be 3, and index will be 1. So let's try it out. Indeed, in the first iteration we have access to the first 2 elements of the list, and in the second iteration we have access to the second and third element of the list. And things like that will be very useful when we start to interpolate between nodes, for example. Then we always want to have a source node and a destination node so that we can interpolate between the two. Then there are some smaller things that I also want to mention, because we will use them when things get interesting. And that's first is a special syntax for multi-line strings. So I've here put a variable f, and I've put in it what seems to be 3 strings, but it's not 3 strings, it's really just 1 string. So as long as you put strings on different lines with nothing in between, so no spaces here, for example, all these strings will be concatenated automatically into 1 string. So to compare, I have here put A, B, C on separate lines in a variable f, and I here put A, B, C all together in a variable g. And when I post both of these variables to the post window, I expect to see the same string for both. And exactly that is what happens. So that's f and that's g. And then there's a final thing I want to mention in this part of the tutorial, and that's a very dangerous pitfall, something if you come from other programming languages you will be bitten by. So be very careful with that. I cannot stress this enough, it's very dangerous. And that's the order of operations in mathematics. In most programming languages, if you write 1 plus 2 times 3, the programming language will first calculate the multiplication and only then do the addition. So that's also how we do it in normal mathematics. So you expect the result of this sum to be 1 plus 6 is 7, but SuperCollider decides it will do all the operations in a strictly left to right order. So if you write this, it will calculate 1 plus 2, which gives 3, and multiply that by 3, which gives 9. So if you really want to have the 2 times 3 calculated first, you have to put it between brackets, like I did here. And we can execute this code to see if I'm not lying to you. And indeed, you get, if you just write this, you get 9. And if you write it with the brackets, you get the expected value of 7. Very dangerous, and you will be hit by that if you're used to programming in different languages. That concludes this part of the tutorial. This was the very basics that we need to get started with algorithmic composition for this project. In the next part we will tackle specification of musical fragments and also using events as objects, which is a slightly more advanced subject, but I will be using it heavily in the tutorial. So it's important to have a look at it. See you then.